Hey everyone, today on Into the Terminal, we're going to be talking about special permissions, Umask, and file ACLs. So why don't we jump right into the terminal and start? So in our last episode, we talked about the regular file permissions of read, write, and execute that you could put on files and directories. But this week, we're going to start off by talking about three additional known as special permissions. And Nate, what are those three special permissions that we're going to talk about today?
So we've got the SUID, SGID, which I'm sure we'll
Yep.
talk about a little more in depth to define what that means when I throw out those acronyms. Sticky bits, and we're going to touch on ACLs. Did I get them all? I think I got them all.
Yeah, well, the specials are SUID, SGID, and sticky. And then we will be talking
Okay.
about setting individual permissions too after the transition. So SUID, that was the first one you said. And you can observe it in the wild here on the user bin password utility. So Nate, where is this SUID?
They show up in the first column there, don't they?
Yeah,
Oh, right there, right
they'll,
there.
yes,
Okay. Little
yep,
S
in
there
the
instead of
user.
R, W, and X.
Yeah. So SGID, we could see that in the wild too, right there. So Nate, can you tell me where the SGID permission is?
It shows up under the column for the group permissions, that little S there. See, I'm
Right
catching on,
there.
Scott.
All right. And then the last one is Sticky, whose official name is SVTX. And we can see that here on the temp directory. So where's Sticky permission, Nate?
It must be that last second to last one there, the T.
Yeah. So weirdly enough, Sticky is special in a whole bunch of ways. One is it doesn't have this cool name. SVTX is goofy. And then
Yeah.
instead of an S, like the others, it shows up as a T. But
Well,
all
it'd be
three of them share.
confusing. It'd be confusing if it also had an S, right?
Would it though? But all three of them show up in the execute field of the appropriate group of permissions that they sit in, right? So SUID shows up in the execute field of of users permissions. SGID shows up in the execute field of group permissions, and Sticky shows up in the execute field of others permissions. All right, so the last thing we're going to do with critical path is we're going to just set one of these. And then we're going to transition and we'll talk more in depth about what they do, how to apply them, and give some additional examples. And then we'll move on to some of our other topics today.
Wait, is
So
there going to be more whiteboarding, Scott?
there will be more whiteboarding. I know how much you love it, Nate.
I hope you guys are looking forward to some whiteboarding.
All right. So here is this file that I just created. It's got some default permissions on it. And we are going to assign some additional permissions to it. So last week, when we talked about setting permissions, we talked about a couple different modes. One is the like specifying with the symbolic notation, where U plus or minus something or U equals something. And then we also talked about octal mode, which is where we did the numeric point system. And then based on the number of points we assigned a user group or other, it translated into a certain amount of permissions for them. Well, it turns out that you can set the special permissions in this way too. All right, so we're going to set SUID. So I'm going to say chmod u plus s on this file. All
Yay!
right, and there's the SUID permission now applied to this file.
But why
You
is
can
that S
also do
capital and the other one's lowercase?
get to that after the transition, Nate. Stop asking
Oh, I'm
leading questions.
sorry. You'll just have to wait.
And you'll actually see a change. Our next change is SUID typically applies to executable binary files. And notice this file doesn't have execute permissions at all. So maybe I want to
Hmm.
add some executability to this file. So I'm going to use the octal mode, chmod. 4 is the number of points that correspond with SUID. 755. So 7 is read, write, and execute for the owner. 5 is read, execute for the group owner. And the last 5 is read, execute for the others. All right, so when I apply this change, whoops, and I tell it what file to make that change to,
Yeah, that helps. Oh,
right? So
look.
we go.
Sweet.
Yeah. I will warn you that when you use special permissions and octal mode, right, the numeric mode of setting permissions, if you want to retain your special permission, you always have to put that value in the permission change because the default number to assign for special permissions is 0, right? So
So
if
if
I
I
just,
just did a 755, it would clobber it.
yeah, it would turn it off,
Yeah.
right? Because the default, if you don't specify that leading fourth digit for specials, is it's set to a 0. Specials should be turned off. So if you're using special permissions, you need to remember when you're working with that file to always include that leading fourth digit, which tells it what specials to apply to the file. All right. So stay with us after the break. We're going to go into a lot more depth on uh, special permissions, what they do, how they apply. We're going to do a little bit more whiteboarding that Nate loves. And then we'll transition to talk about some additional permissions topics, specifically Umask, which is a setting that determines the default file permissions that someone gets on a file or directory they create. And what was the other one, Nate? This is the quiz before we transition.
The other was ACL, wasn't it? Sorry, I like drifted there for a second. Let's just,
Listening to the
you know,
soothing sounds of my voice. Um,
yeah, that's it.
ACLs, which is a method that you can apply permissions that apply to a specific person or a specific group that may not be the owner or group owner of a file.
But we're
So
going to
don't
try
forget
to
to
avoid brain melting ACLs, right? We're just going to
correct. Very
some
simple.
basic ACL. No brain
Yeah.
melting today.
So don't forget to mash that like and subscribe button so we know you like the content and you can get notified when we make more of it. So I'll see you after the transition. All right. So here we are,
Welcome
Nate.
back. Here we are, talking about special file permissions.
That's right. Amongst other things, now is the time where if you are joining us live, ask questions in the chat and we'll address them. Um,
Yeah, yeah.
much to, and maybe we'll even go longer than our normal 30 minutes.
No, we won't. We will try our best not to do that. Right, Scott?
Yes, I'm just poking at producer Eric behind the scenes. All right. So why don't we jump into our whiteboard? I'm going to have to do a little bit of screen swizzling here for producer Eric to show my whiteboard when I get it selected. There we go. So special permissions work like other permissions on files. So last week we talked about the octal mode of permissions, and we said that read is worth 4 points, write's worth 2 points, execute's worth 1 point. Well, it turns out that SUID, SGID, and sticky are also worth points. So SUID is worth 4 points. We saw that in the critical path when I was assigning it to that file, right? I used that leading fourth digit of 4 points. SGID is worth 2. And SVTX, which is colloquially known by its nickname,
Sticky.
Sticky, is 1 point. All right, so Nate, I have a file.
Mm-hmm.
I don't know why I have these permissions assigned to it, but I do. What if I
Well,
want to,
you don't want anyone else to execute it but you and your group. Simple.
I guess, what if I wanted to apply SUID and SGID to this executable? What chmod expression would I use?
So you would chmod it. The first number would have to be 6, right? So 6, 7, 5, Three, three, four.
All right. And after we applied this change to this file, it would now look like this. Right, we can see the SUID and SGID permissions there in their respective execute field of the permissions. All right. So before we transitioned, Nate, you asked a great leading question that I told you to hold. Actually, I said don't ask questions, but now I'm going to tell you ask the question. So when we made the change originally, we saw this on our file
Yep.
or something like that.
Something like that. Yeah.
And yeah, and you noticed this. What was different?
So by the example from earlier, I think that the difference was executable was not set when you set the sticky bit, or when you set SUID,
Right.
because when you set it, it went to lowercase.
Right. So because the special permission shares that execute field, we
Yeah.
have to have a way of visually seeing whether execute is or is not there. And the way that we visually see that is whether it's a capitalized special permission or a lowercase special permission. So in
Right.
this case, where the permissions are all lowercase, we know that this is 6754. And over here, where it's uppercase, that tells me that execute is not, well, thank you, camera. It tells me that permissions, the execute permission is not present. So this would be a 4644. And so when we did a permission change that added the execute permission, it visually changed to a lowercase s so that we could now see that both the execute was present and also the special permission. In the examples that I showed of password, the write command, and temp, in all three of those, the permission was displayed lowercase. And remind me again,
Right.
Nate, what does lowercase special permission tell me?
Lowercase means that executable was set.
Correct. And so that's how you kind of read the permission sets. Um, cool. So, uh, points, how we set them. We're in a pretty good shape here. You got to use that leading fourth digit. Um, and I think we can jump into where they're applicable. So why don't we switch
Yeah.
back to terminal, which
So
means I
now
got
we
to
know how
do
to set them, but what
bring the
the heck do they do?
exactly. All right. So let me clear this off. So our examples were user bin password. All right. So what happens when you have an SUID binary? SUID stands for set user ID. So when you run this command, password, to change your password, while the command is executing, it is actually executing as the owner of the file. So Nate, when I'm running the
Ah,
password command, who is this executable running as when I'm executing it according to these file permissions?
it runs as root.
Yeah. So because root is the user owner of this file, when I run it and we see the SUID permission is there, we will, during the execution of this program, temporarily switch you to be root because that's the user ID that owns this executable. All right, and that's important because what kinds of things are you doing when you're using this utility, Nate?
Well, you're changing user data, writing to Etsy password, Etsy shadow, things that you're not allowed to do otherwise.
Right. And so, like, if we look at Etsy Shadow, where the passwords are stored,
Yep.
right? I can't make changes to that. In
Like
fact,
nobody can make changes to that. Root only can because they're root.
that's right, because they ignore permissions because they're administrator and they can do what they want.
Right.
And so it's this like temporarily switching of effective user ID that allows this to work. Now, that actually is kind of scary too. And you'll notice
So
that the long listing with colors output shows us it's scary.
yeah. But to take a step back, right? The reason this has to work this way is because password is not only executed as root. You might think, oh, well, that's a tool that root only uses anyway, but it's not. Any user that changes their password needs to be able to write to Etsy Shadow to store their new password hash, right? Which is why this has to work this way.
Right. But that means that anything that the program does also is happening with the rights and context of the root user.
Right,
And so the actual executables are extremely lovingly crafted and
right.
tested to make sure that there is not a possibility for off-path behavior to occur on the part of the user, right? There's a very finite list of things the user can do when they're running this utility, finite list of things that they can interact with this utility. That way somebody isn't able to like break out and do random things
And
with
just
root
just
authority.
imagine an arbitrary code vulnerability in Etsy password. Or sorry, user bin.
And you know what? Like a bajillion years ago, that actually was the case.
Yeah,
Um, you know, the password has been around since pretty much the beginning of Unix, right? And
yeah.
so buffer overflows and like all kinds of stuff that happened. Those were there. And in the 80s and 90s, we kind of wrung all that out and figured it out and fixed it. So now it's pretty bulletproof. But that means that if you are using a third party, right, not native to this system, SUID binary, that should give you a monopause to say, is this really needed? What does it do? How confident am I that somebody can't exploit something that might be flawed in this
Right,
execute? Right. And
right,
you certainly
right.
don't expect to see these things like scattered around in the directory tree. So it's highlighted red for a reason. Danger, 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 danger. And
So
we
you're
want to make
saying
sure
I shouldn't set UID on like bin bash.
that would be really bad because then every shell would
Every
run with
shell would be root.
right. That'd be real bad. And in fact, that's one of the reasons why some of the utilities that we use for figuring out what our file system and files look like periodically, like AID, intrusion detection software. That's one of the reasons why it captures permissions as part of its as part of its
Yeah.
intrusion detection.
Yep.
Because somebody dropping a SUID binary somewhere or on an SUID permission on something is something that you would want to know about as an administrator.
Right.
All right. So SGID, we saw that in the wild too. Right. So you run the write command, which will write to someone's terminal. Right. Actually,
Yeah.
like pops up a message. Wall is actually the write all command. So it uses write to make its changes. Um, it's SGID'd. You see that there in the group field. And so when you run the write command, you temporarily become a member of the TTY group.
Right.
And then write command executes and writes to some TTYs. And when it closes, you go back to being in your normal group memberships. So uh, when someone runs an SGID to binary, they temporarily assume the rights and privileges of the group that owns the executable during the running of the executable, and then go back to being themselves. All right, it turns out that SGID and SUID only work on executable binaries. You can put them on a directory, they don't do anything. You can
Right.
put them on things like shell scripts, but they don't do anything. So it has to be a compiled executable binary.
Oh, so I couldn't make a shell script that would also respect that. Okay.
Correct. So you can
Kind
make
of
a
makes
shell script
sense.
and you can assign the permissions to the shell script, but when you actually
Yeah.
try to leverage those permissions, it will not work.
Right. That's what I mean. It wouldn't respect them. Like you could set them, but it wouldn't honor them. Honor is maybe the word I'm looking for.
Correct.
Honor and
Right.
respect are so very similar words that it's
They are. They are indeed. All right. The last special, and it's the weird one.
Yeah. I've been waiting for this one because I've never really, I think, understood what sticky is for. I've
All right,
probably
so there's
leveraged it and
actually a
never
couple of
knew.
places. There's a couple of places where it lives normally on
Yeah.
Red and Linux systems, temp and bartemp. And again, colorized ls like shows us the thing, right?
Yeah.
It indicates with colors this is a stickied directory. Essentially, what it says is um, even though this directory is writable by everyone, right? User,
Hmm.
group, and other. Everyone has write permission on this directory. And normally, when you have write permission on a directory, you can add files to it
Hmm.
or
Delete files.
remove files from it.
Remove
Yeah.
file. Yeah.
And and so like in temp, where like different desktops from different users are putting temporary files, or
Yeah.
some application might be putting a temporary file, it would mean with no checks and balances that any user could remove anyone else's stuff from this directory.
Probably not good.
That's Yeah, and that's what sticky solves. Essentially, when sticky is applied to a directory, it says that only the user that owns the file in the directory can delete it.
Ah.
So that
What
keeps
about
other users from deleting each other's things.
just delete or modify as well?
Well, modifying the file is a file permission thing, right? Because you're changing the contents
Yeah.
within. So that's going to be determined by whatever permissions are on the file that gets dropped in the temp directory. But you can add what you
Okay.
want to the temp directories because you have write permission. You can only delete your own things from these directories because of the
Uh-huh.
sticky permission. All right, sticky can also be
It's
applied to files, but it does not do anything, right? So it is
okay.
not honored, as Nate would
It's
say.
it's still kind of a weird name. Sticky. I don't know if I
Mm.
have a better name. But sticky doesn't really bring that to mind. I would have thought sticky would have been like preserving permissions or something like that, but
So originally, and this is why it's a T, is originally called the tacky permission. And I don't know
that sounds
why, but like
tacky.
sticky and tacky, right? They're kind of like this similar description. It's
Similar.
kind of like respect and honor, right?
Kind of like respect
Uh,
and honor.
right. So, but its name was changed from tacky to sticky because effectively your files are stuck in the directory until you delete them.
Okay.
Um, but because it was originally called tacky and its symbol was a T, the T has persisted throughout the history of Unix.
Yeah, I can understand that.
All
Because
right.
someday
So
somebody else might want to use S, and they'll think it's not used, and then you'll be in this weird situation, and we don't want that.
when do we ever have weird situations on Unix and Linux?
Never.
All right. So again, you could put sticky permission on a file, and it'll show up there in the permissions field, but it won't actually do anything special when placed on a file. It only does something when it's placed on a directory. All right. Um, cool. So we've observed them. We did some changes using the two modes of setting permissions, both symbolic and octal. Do you want to move to the next topic, Nate?
I think that's probably a good idea.
All right. So let me become a regular user for this one.
And if anybody has any questions thus far, feel free to throw them into chat. I haven't seen anything come through. Some commentary, which has been good. Some hellos. Hi.
All right. So the next topic is Umask. So Umask is a setting that's applied to every user, and it determines the user's permission mask, the Umask. And so when you run the Umask command, it displays what the Umask is set to.
Yep.
So this person is 0022. All right, so let me flip back to ye old whiteboard that everyone knows and loves. All right, and producer will pull that up in just a second. And here's how it works. So we know that permissions are a 4-digit value. Specials user group, and other. Right? This is the UMask that we just saw as the rel users UMask on the previous page or previous screen share. And what we're looking at is the permissions that should be masked away by default on someone's freshly created file or directory. So when I create a file, there are some maximum default file permissions I can have. So if I had no UMask, that's the permissions that my files would have. So if my UMask was 0000, this is what would happen when I touched a new file or created a new file. So the UMask says mask away 0 specials because they're not given by default. Mask away 0 to the default user permissions. Mask away permission value 2 from the group and permission value 2 from the others. So I'm going to ask Nate a question. Does he remember what permission value 2 corresponds with?
Right. Isn't it?
That's correct. It is write permission.
Hey!
All right. So basically, what we're saying is, oops, sorry, that's a 0. That's our mask. And the way a mask works is it's like an XOR. So if the permission is turned on, we will mask it away, thereby turning it off. If the permission is not on, there's nothing for us to mask away, so it won't actually do anything. And so what we end up with after we apply the mask is this. Read, write, read, read. Same
Right.
mask applies with files and directories. So on directory, that's the maximum default file permissions I could get. So we apply our mask. And what will happen is if I use mkdir to make a directory, the write permission is masked away, and this is the directory permissions that will be there by default for me. So let's do another set of these. I'm going to use the umask command in my demo in just a minute, and I set the umask to 0077. And we're going to do the same thing. So my maximum files look like this. And my maximum directories, oops, look like that. And I'm going to apply this 0077 umask. And I'm going to get to my new default file permissions. So with a 0077 umask, when I create a file, it's going to be read write, nothing.
Because you're masking away every permission.
Yeah. And even this one where the execute's not set, well, if it's not set, I can't mask it away. So it's still not
Right.
set masking.
Right.
Right. For directories, we're going to be read write execute for the owner, nothing for the group, and nothing for others. All right. So let's flip back to the terminal share. And I'm going to go ahead and assign this mask. All right, so I can verify using the umask command what my currently set umask is. And so when I create a file, that looks like what
There
we
you go.
saw on the board. And if we create a directory, looks like what we saw.
There you go.
All right, but this change that I made with the umask command is only for this shell.
Yeah.
So if I log out and log back in, it goes back to the default.
Right.
Or if I open up another shell because I'm in a graphical desktop on my server, I'll get the default umask again, the 0022. So the way that we make this a permanent change is we go into our .bash rc in our home directory. I'll just make sure it's not already set. We'll go down to the very bottom.
Yep. Just throw umask in there.
And now this is my my personal setting for umask, and it'll apply to every shell that I create on this machine from here forward. All right, so .bash rc is an environmental variable script that gets run every time you create a shell, and it is for running commands, hence why its name is RC, running commands. All right.
You could set that globally in Etsy profile or just Etsy bash RC.
I think it's Etsy bash RC, but let's look.
I forget if there's a better way
Oh,
to do that.
globally.
Be careful setting it globally though, because it affects every user.
All right, so
Keep in warned. There it is.
Here is the thing. It says if umask is equal to 0, right, meaning it's not set,
Right.
then and set it to umask 022. Notice it didn't provide the fourth digit. It's because default file permissions don't have specials by default, so turning it off with your mask doesn't really matter. So you can
Right.
use the user group 3-digit number and be just fine. But so that's where it would be set globally for all users. This has actually changed. Later versions of Red Hat Enterprise Linux are more restricted in their UMask. They remove group permissions by default. In the olden days, we would use a UMask of 002, which helped with shared groups and sharing group files with other people in your shared groups. All right, so that's UMask.
Yeah, umask. Useful
Last,
tool. I mean, there are uses for that. It may sound simple, but every now and then you'll run into a case where, like, dang it, I wish these permissions were different by default, and now you know how.
well,
Now we're
kind of.
ready to blow everybody's mind with ACLs, right?
Yes. So we're going to create a file here. All right, so here it is. My cool file has my new default permissions, right? Because I made them permanent in my bash RC. But it turns
Yeah,
out
there you
there's
go.
another Joe that needs access to this file. And traditionally, there's a couple of ways that we could do this. One is the administrator can make a group that I share with Joe. And I could make the group owner the same as this shared group that I have with Joe, and then I have to adjust the permissions a little bit to make it so that Joe can access this file. However, there's another way. Nate, you know the other way.
You'd use a file system ACL or a
A
FACL.
file, yes, a FACL. So what we can do is we can set FACL and say that the user, Joe, should get read and
No
write
question
permission.
marks. There you go.
Whoops, sorry.
You got it wrong. What would we do wrong? Oh, you need the dash M, don't you?
A, right? Is
Dash
it M?
A,
Yeah,
add.
there we go.
M is modify, I think, and A is add.
All right, so something different happens
But
in my.
it didn't actually change. Oh no.
It did.
Well,
It actually
it
changed
kind of
it.
did. Look at that.
Yeah,
Cool.
one is thanks to a weird ACL masking that we're not going to get into today because it'll make your brain explode. Some additional
Yeah.
permissions for the group. The other thing is there's now this plus sign.
Yep.
The plus sign indicates that ACLs are present on this file. And so when we're just doing an ls-l, we're not getting the full story of permissions on this file. So if we want the full story, Nate, what command do we have to use on this file?
You'd use a get facal. So get FACL on the file. And it should show you a nice little table, sort of table, list of the ACLs.
Right. So the user has read-write permission. The user Joe has read-write permission. And then we're not going to get into the masking and other stuff, but that's
Yeah, you can get super crazy with ACLs. We used to use ACLs in a Samba file sharing setup that we had because we had a ridiculous number of users and groups that needed access in different ways to the same files, and it just got way difficult to manage. We'd cooked up a database that would write out ACLs. It was I don't recommend going down that road, but you can get crazy restrictive or unrestrictive with ACLs, and that list can be like a billion lines long.
yeah. And so what when we're reading the ACLs, what it's really saying is that even though Joe is not the user that owns this file,
Yeah,
the user Joe, only Joe, should be given read-write permission to this file. And so last week when we talked about basic permissions, we talked about how when you interact with a file, the first thing gets checked is the user that owns the file. And if you're the user, you get user permissions. Well, now Joe is also considered a user to this file, and we'll apply those permissions and stop looking. So even though according to file ownerships, he's an other, because we have this special ACL listing that lists him as a user permitted person, he gets those permissions and we stop looking for anything else.
right.
You can also assign group permissions. So instead of U colon some name, it could be G colon some name.
Yep.
But there is one other thing we have to do for Joe on this one. So because we've given access to Joe for the file, but can Joe get into the directory that holds the file?
No, Joe cannot get into the directory that holds the file.
Oh, because the only person that can get into this directory is the rel user. Right?
Yep.
Everybody else has no permissions. And so in order to really give access to Joe, yes, we have to add him to the file, but we also need to give access to the directory structures that lead down to the file too.
Right. Which could be done with another ACL or a group permission, however it is you want to deal with it. But since we're talking about ACLs,
All right. So again, we get that plus in the last field that says, hey, these long listing permissions, not the only story. You got to use get FACL, get facal to see the whole story. And so now if I SU to Joe, I can edit this my cool file. Right. And because I have read and write permission, I can only access the file. I can also save my changes. Right. And that person can interact with the file. Any other person on the system, they're an other to this file. And so they wouldn't be given access to the user's home directory. And also they wouldn't be given access to this file.
right.
All right. So I think that runs us off the list of our content today, Nate.
I think it does. There's a handful of questions in chat. One of them was around why did the group permissions change? Yeah. Which I don't know. Do do we really want to try to because just for the sake of time, right? It could get complicated.
Yeah. So the reason the group permissions changed was because of the mask that is being assigned in the ACLs. So
Right.
if we bring back the screen share, this right here is what is affecting that group permission as well. So that's why we
Now,
could change the mask to zeros, and then that would leave the
did
permissions.
the did the mask simply get added by default because we started using ACLs? I guess is really the crux of the
Correct.
question. So then you
That
could
is
go
correct.
back and remove the mask, and then the problem would, the perceived problem would go away.
Correct. Now
Right.
we use user private groups on Red Hat Enterprise Linux. So
Hmm.
when we granted those read write permissions by default, who got them? People in the rel group, because that's who by
Right.
default owns your
Oh,
files is
right.
your private. So yes, it got added. It's a little bit weird, but in normal circumstances, it doesn't actually give anyone extra permissions because you already have those permissions as the
You
owner of
would
the
have.
file.
It's the reason it changed it was mainly, or the reason you saw the change is because you had changed that UMask.
The other place where you would gain from this is oftentimes ACLs are used for shared files and directories. And I
Hmm.
mentioned that uh, RHEL made a change and we no longer use a 002 UMask, we use the 022 UMask, which means that over time, our group permissions have gotten more stringent by default. And so by
Hmm.
adding the um, read write back into default permissions for groups with ACLs, if you use an ACL to set a group access, it would automatically cover them under the group owner. So if you're using things like an SGID directory, where when files are placed in the directory, they automatically change their group ownership. Well, that's something we forgot to mention. Um, that's where that would be handy. All right, what are our other questions?
I thought there was another something about user Joe. Here we go. What if user Joe attempts to open a file via the full path instead of listing the directory? I think this was after you had made the ACL changes to your home directory so that Joe could then get in and modify the file
Yeah.
or get to the
So
file.
let's go other direction. Oops, that created two files.
Yeah, well,
There we go. So if we do a set facl-m user rel read write,
on Joe's file.
right? So um, basically, I just set up the same thing but in reverse, where
Yeah,
rel has the read write permission on this Joe's file, but I have not yet added the ACL to Joe's home directory to permit access.
right,
So let me go back over to rel. What I expect to have happen is a permission failure
right.
because
Because they
rel
can't
does
get through
not
the
have,
directory.
yeah, they don't have permission to access the directory, which means they're not allowed to access files in the directory, even those that they may have permission to use inside the directory, because they don't have execute permission on the directory, won't work. So there you go, permission denied. And in fact,
Yep.
if I try to use tab completion, it doesn't
Doesn't
work
even
because we're
show it.
not able to access the directory to then read the
Right.
files to then um, fill out tab completion.
That's
Um,
all the questions I saw. I don't think there were any others.
Excellent. We're only 16 minutes over today. Producer Eric should be proud.
We're getting better.
All right. So don't forget to like the content if you like it, and subscribe if you want to be notified when we're doing more of these. Speaking of more of these, Nate, what are we doing next week?
Next week, several of us will be in Denver, Colorado at Summit. So, unless you're in Denver, Colorado, you will not see us next Friday. In fact, next Friday, we'll probably all be on airplanes going home from Denver, Colorado. So, you still, unless you happen to be on our flight, also not see us Friday. So, but you may see us during the week if you're in Denver, Colorado.
Yeah, so
That's not saying you
definitely
should stalk any of us to find our airplanes to be. Yeah, that's way too like we love fans, but that might be too much.
challenge accepted, Nate. Um, So Nate and Eric will both be working the Red Hat Enterprise Linux booth at Summit, as well
Yeah.
as doing some sessions. So if you're at Summit, please feel free to stop by and tell them how much you love them, and maybe give them a hug. Well, maybe not a hug. How about a handshake or a high five?
Handshake, high five, that's fine. I might even be okay with hugs. I guess it depends.
Um, so we will not be doing an Into the Terminal next week, but we'll instead do one the week after. And I don't know that we have a topic for that one yet. We have a big board of topics. We'll pull one off there, and
We'll figure something
producer
out.
Eric, yeah, producer
Yeah.
Eric will do his magic. Like we'll put in the channel before showtime. So
Yeah. Speaking of, make sure if you haven't already, or if you're not aware, you should check out our new Discord community. It hasn't even been around a month yet, so we're still building that community up. There's currently a QR code on the screen. If you want to scan that, it'll get you in. Although I don't know, is it cut off? No, it's only cut off on my screen. You should see it fine. But yeah, check it out. If you're listening after the fact, I guess. Well, no, it'll still be there. I'm rambling now. Go join Discord.
yeah, somebody asked about Summit. So keynotes will be streamed live from the event. You can see them on the Red Hat YouTube channel, not the Rel channel where we are, but the Red Hat YouTube channel. And then I'm actually working with another team on maybe doing some filming of the Summit sessions and posting them around. So nothing finalized yet, but we're working on it. Typically, we don't record Summit sessions, but maybe that will change this year. We'll see.
There
And
you
then we'll
go.
post them after if we get that done.
And no, we're not going to live stream into the terminal from the booth. We did do some Rel Presents episodes last year from the booth, which were fun. I don't think that's happening this year, though.
No, I don't know. Maybe next year we'll try taking a year off and see what happens, and then maybe next year we'll change.
There we go. We need a production
All
crew,
right.
though.
If you are a deferred viewer and you've made it this far, congratulations. Don't forget that you can put comments in and we will respond to them, of course. Um, I think that's about it. Nate, any final words?
No, I mean, we'll see any of you that are there at Summit. And otherwise, we hope you have a great 2 weeks. We'll see you in 2 weeks.
Great. Happy Indela Terminaling, everyone.
Have a great one.